Now let us take another question. The function is defined from r minus 7 5. It means that accept value this minus r to minus 3 by 5 be defined fx equal to 3x plus 4 upon 5x minus 7. This shows that x cannot be equal to 7 by 5. And g is a function defining from g r minus 3 by 5 to r minus 7 by 5. Be gx equal to 7x plus 4 upon 5x minus 3. Then we have to show that f composition g is equal to ia and g composition f equal to ib, where a is given to be this set and b is given to be this set. Now here let us see the question. The range of the function is equal to domain of domain of g. We can say range of the function f is equal to what? Domain of g, because these two are what? Equal. And range of g, if we are defining composition f to g, then here we can say that the range of g is equal to what? Domain of f. So we can say g composition f and f composition g existing by definition of what? G composition f and f composition g. If g composition f is defined, then the range of f is equal to what? Domain or the subset of the domain of g. If f composition g exists, then we can say the range of g is either equal to domain of f or the range of g is a subset of domain of f. Therefore, both these are defined. Now, it means f composition g is a function from what? F composition g is a function from what? A to a. Our a is what? R minus 3 by 5. B is what? R minus 7 by 5. So, therefore, f composition g is a function from what? A to a, and g composition f be a function from this to this. And another function from will be from this to this. This is what our b and this is our a. Therefore, f composition g is a function from a to a and g composition f is a function from b to b. Now we have to prove that this is equal to identity function. First we are finding for x belonging to, because f composition is defined from a to a. For x belonging to a, f composition of gx equal to f of gx, putting the value of gx here. Again, f of 7x plus 4 upon 5x minus 3. Now our fx is what? 3x plus 4 upon 5x minus 7. Putting this value, simplifying this expression, we are getting this is equal to x. It means image of this element under f composition g is the element itself x for all x belonging to a. Therefore, we can say it is an identity function, or we can say f composition g from a to a such that f composition g of x equal to x. It means f composition g is equal to ia. Similarly, for the second, we have to prove that g composition f equal to ib, means identity element of this set. Now here for x belonging to b, again we can proving g composition f of x is equal to x by simplifying. G composition f can be written as g of fx. Then again putting the value, simplifying, we are getting this is equal to x itself. It means in the image of the element under g composition f is the element itself. So it is what? Identity function. Therefore, g composition f defined like this is an what? Identity function. Therefore, it can be written as g composition f equal to I of b. Again, f composition g is equal to I of a, g composition f equal to I of b, where a is this and b is this. We have to prove in the question. Now let us see the next question. Let f be the greatest integer function, g be the modulus function. We have to find out g composition f of minus f 5 by 3 minus f composition g of minus 5 by 3. This we have to find out the value. This is one of the important questions, can be asked in 1 marks question. Now we have to find out this value. First we will find out g composition f of minus 5 by 3. So it can be written as g of f of minus 5 by 3. Now f is what? Greatest integer function. Sorry. F is what? Greatest integer function. It can be written like this. Now the number is minus 5 by 3. Minus 5 by 3 means minus 1 point something. If the number value of the this is real number is minus 1 point something, then its greatest integer will be what? Minus 2. It means left hand side, the line integers lying on the left hand side of this, and the greatest one is what? Its greatest integer value. So greatest integer value of minus 5 by 3 will be what? Minus 2. And g of minus 2, because g is the modulus function, modulus of minus 2 equal to 2. Similarly, f composition g of minus 5 by 3. It is can be written as f of g of minus 5 by 3. Then again f of, it is modulus function, modulus of minus 5 by 3. Then it is what? F of 5 by modulus of minus 5 by 3 is what? 5 by 3. Now f of 5 by 3 is the greatest integer function of 5 by 3. Now again it lies between 1 and 2, and therefore its greatest integer function will be equal to 1. Now we know the value of this and value of this also. Putting their values and simplifying, we are getting 2 minus 1 equal to 1, the value of this given expression. Now here the last I am going to tell you about what exponential and the logarithmic function that is new to you. Now the function of this type fx equal to a raised to power x, where a is greater than 0 and a cannot be equal to 1. This type of function is known as exponential function. In the previous class we also also listened the word exponent. The word exponent give us what? Exponential function. Fx equal to a raised to power x. Condition is a greater than 0 and a cannot be equal to 1. This type of function is known as exponential function. Similarly, fx equal to e raised to power x, where e is any irrational number. Value of e always lies between 2 and 3, and approximate e is equal to 2.7. As usual, we are just supposing the value of pi is an also irrational number. Pi is always 22 by 7. Similarly, e is also irrational number and its value is lying between 2 and 3 and e equal to approximate 2.7. This is also exponential function. E raised to power x, e raised to power minus x. All these are what? Exponential function, because these are written in the form of exponent. Now the second function is also the logarithmic function. Now if a greater than 0 and a is not equal to 1, fx equal to log of x with the base a. It will read as what? Fx equal to log of x with the base a, where x always greater than 0 is called the logarithmic function. Listen it again. Both are the reciprocal of each other. Now here if fx equal to a raised to power x and here fx equal to log of x, it will be read as log of x with the base a, where x must be greater than 0 is the logarithmic function. Both are the what? The reciprocal, you can say the converse of each other. For example, if 2 raised to power 3 equal to 8, we know it. Now this can be converted, logarithmic can be converted into exponential, exponential can be converted into logarithmic. Now 2 raised to power 3 equal to 8. So we can write log of 8 with the base 2 equal to 3. Similarly, we know 5 raised to power 2 equal to 25. It is exponential form. We can write down into the logarithmic form. Means log of 25 with the base 5 is equal to 2. These are the two definitions of what? Exponential function and the logarithmic function. Both are the converse of each other. This implies this and this implies this. This is a new function in the 12th class that you are learning, exponential and logarithmic function. Now here the question is here, f is a function from R to R given by fx equal to log of 1 plus x, and g is a function from R to R given by gx equal to e raised to power x. When no base is given, we always assume the base is e. Now here these two functions are given. We have proved that g composition f is not equal to f composition g. Now here let us see here g composition f defined in the same way, g of fx. Now the value of fx is what? Log of 1 plus x. Now g of log of our x is what? Now log of 1 plus x, and gx is what? E raised to power x. So therefore by using this it can be written as e raised to power log of 1 plus x. Now e and log both will cancel each other. Therefore this can be written as equal to 1 plus x. See this point is very much important here. Now here it is what? E raised to power log of 1 plus x, and log and e both they will cancel each other. So we are getting this is equal to 1 plus x. And similarly we have to find out f of composition. F composition g of x is, it can be written as f of gx. So now the value of gx is what? E raised to power x. It can be written f of e raised to power x. Now our fx is what? Log of 1 plus x. Putting this value, log of 1 plus e raised to power x. Now g composition f is coming to be 1 plus x, whereas f composition g is coming to be log of 1 plus e raised to power x. So both are what? Not equal. This we have to prove in the question. Now let us see another question. Let f be a sine function, g be a function defined by fx equal to 2x, gx equal to 2x, h be a cosine function. Prove that f composition g equal to g composition f h. F into h means the product of two functions. Now here fx is sine function, fx can be written as fx equal to sine x, and gx is equal to 2x, and h be the cosine function means hx equal to cos x. And now here f into h function, it is the product of two functions. It can be written as f of x into h of x. So it becomes sine x into cos x. Now sine x into cos x. Now multiplying and dividing it by 2. It becomes the value of what? Sine 2 sine x into cos x. It can be written as what? Sine 2x. It can be written as sine 2x by 2. In the 11th class, we know this result. Sine of 2a, 2 sine a, cos a. So therefore, 2 sine x into cos x can be written as sine 2x by 2. Now this is the f into h of x. Now here we have to prove that this equal to this. Firstly, we see that these functions are existing. Now here, in each case, the domain of f is R. It can be defined for every real number. Therefore, domain of g is again R, and domain of this function is again R. And similarly, the domain of this function f into hx function is what? Sine 2x by 2. Again, it can be defined for every value of x. Therefore, the domain of f, domain of g, domain of h, and the domain of fh again is R, the set of real numbers. Similarly, the range of f, we know sine and cos always lies between 1 and minus 1. Therefore, the range of the function is, range of f is closed interval minus 1 to 1. Range of g is, it can be defined for every real number. So here the range of g is R. Similarly, the range of h is, it again lies between 1 and minus 1. The range of h is closed interval minus 1 to 1. Therefore, similarly the range of fh. Now our fh is sine 2x by 2. Now the range of sine is what? Minus 1 to 1. So therefore the range of sine 2x by 2 is what? Closed interval minus 1 by 2 and 1 by 2. This we have defined the domain and range of all the function defined in our question. Now here we have to see here. Now f composition g. F composition g will exist if the range of g is the subset of what? Domain of f. And g composition f of h exists when the range of fh must be the subset of the domain of g. Now here the range of g is equal to, the range of g is R, is equal to domain of f. So we can say f composition g exists. Similarly the range of fh, the range of what? The range of g composition f of h. The range of fh is what? Minus 1 by 2 to 1 by 2 close interval this. Again it is a subset of what? R, the set of real number. So we can define g composition f into h can exist. F composition g can also exist. G composition f into h will exist. Now we have to prove that these are what? Equal. So let us prove it here. F composition g of h, f of gx. F of gx means it is given a f of gx is given to be 2x. It should be a 2x. Therefore, it should be equal to sine 2x. Correct it. It should be what? 2x here. It is equal to what? Sine 2x. Similarly, G composition F into H into X can be written as G F into H into X. Again, Fsx is what? Sin x into cos x. So it can be written as G function is Gx is equal to 2x. So it is what? 2 sin x into cos x. Then it is equal to what? Sin 2x. Sorry. So we are getting here F composition G is equal to sin 2x and G composition F into Hx. Again it is equal to 2x. So we can say F composition G equal to G composition F into H. We have proved in the question. Now I am just telling you the question asked this year in the board examination. Okay, one question is now here the distribution of marks of this very unit and the next unit. First unit is relation and function. Second is what? Inverse trigonometrical function. Total distribution of marks of these two units is 10 marks. Now this year the question has been asked from this very unit is the first 1 marks question. Another question is of 4 marks question. It is on the inverse of the function and this question is with the choice from the question from inverse trigonometric function. And the third question that has been asked in this year paper, that is on the relation and the set of the natural number. We have to prove that this is an equivalence relation. So maximum there the total distribution of marks this year in the paper is here 4 plus 4 8 plus 1 9 marks. Now we have to do this question. This is all about today. Now this chapter is completed. Now we have to complete it this chapter at your home.